Introduction. So yes, this is going to be a Terraform one-on-one. Really, my goal for this talk isn't necessarily to give you guys a deep dive into how AWS works, security groups, IAMs, or even necessarily a deep dive into Terraform. Really, my goal for the talk is for anybody in this room to feel like they could go home right now and throw up some infrastructure and start writing infrastructure as code. If I don't manage to do that, please do come up to me right after this talk and I'll try and bridge whatever gaps. So quick overview, I'm just going to cover really what it is, the various components of Terraform. We will create an imaginary napkin brief and then just jump into code and build it. So Terraform is a tool that allows you to build, version, and change or reason about your infrastructure. Like many things, you can go to any cloud provider and you can clicky in the interface and do this stuff just fine. But really the advantage in Terraform is that it gives you the ability to reason about all that stuff with code. So that gives you pull requests, that gives you static analysis, that allows you to write tests for your infrastructure. It allows you to do diffs as well, so you can make a local change, and before you actually commit that, it'll say, hey, this is what's been deployed remotely, and this is what you've just asked me to do. Are you sure you want me to nuke the cluster? And Terraform's extendable. It's written in Go, as are all of its plugins. So we had a real-world use case recently where I needed to introduce capability to Terraform that allowed you to upload your own private certificates and use them about your infrastructure, which wasn't previously in Terraform, and I built that in an afternoon. So it's really user and developer friendly. And there's an enterprise option if anyone here like me. Any enterprise people? No? Yeah, so if you need to convince the legal cats that it's a tool you can use, you can pay a lot of money for it if you like. So this is the super top level makeup of what Terraform is. The tool that you tend to see is the CLI. That's how you tend to invoke the commands. But most of your work's going to be spent in code. So you define your provider. So a provider could be VMware or Azure or GCP or AWS or Kubernetes and GitHub. There's a whole bunch of different providers. And then depending on which provider you choose, you inherit resources that you can use. So in today's example, we're going to use AWS. So if in our code we say that we want to use the AWS provider, we then have access to AWS _ Lambda or EC2 or S3, etc. It also manages state in order for it to be able to do things like diff configurations between what you've changed and what you've previously deployed. It needs a point of reference to check that. So by default, Terraform uses a local file as its backend, but as you're working with teams, it's wiser to put that up in S3 or there's many other options available. And finally, off the back of backends, you can split a backend for a particular configuration into multiple states. So workspaces allows you to do that. For example, if I wanted to deploy dev, but the person next to me wanted to deploy dev with their feature tweak, they could deploy all of the same infrastructure separately by creating their own workspaces. So the configuration language for Terraform looks a little like this. In this particular example, that's all the code that you will likely need to hook Terraform up to your AWS account. There is a prerequisite here that I already have previously set up AWS CLI on my laptop, but assuming you've done that and you've got your default account pointed at your AWS account, this is all the Terraform code you need to be able to speak to it. Because I've used the AWS provider, this is one of the resources I can now use. This particular example is the EC2, the VM that offering from AWS. Beside AWS instance, you can see we give it a name. That's just so that throughout our code we can reference it. So let's say you wanted to pass in the instance ID that's created from a particular resource into a Lambda function, or you want to write that as a file into S3 or something like that. Later in our code, we can point at the web AWS instance resource and then extract attributes or outputs from it into further resources. And the backend, If you choose to have a backend configuration, you want to store your state externally, which of course is wise to do. Again, it really doesn't take a lot of code for you to push it up to S3 and start sharing the same backend state with the rest of your team. The CLI, generally this is what people think of when they see Terraform. It's a super feature-packed little binary that will allow you to apply, destroy, plan, as we'll see in our demo. And onto the live demo. I feel like I'm flying through this. Okay. So this obviously is 100% reliant on an internet connection. So I'm positive that this is going to go terribly wrong. So we have, let me just nuke all the things. So starting with an empty directory, we will create our Terraform code. Terraform is smart enough that if you want to split your configuration across multiple files, as you should do, have a provider.tf, an instance.tf, a bucket.tf, whatever. You don't need to tell it where to point. As long as they're in the current working directory, it'll know where to grab all of those. For the sake of this demo, I'm going to dump them all into the same files to save me just exiting, but it's not a practice I would recommend. So the first thing that we're going to do is pull in our provider and tell it which geographical region we want to deploy to. For those unfamiliar with AWS, it has many different regions for you to use. So if your target audience is based in Ireland, you probably don't want to deploy your entire stack to the east coast of America. Given that you guys are all in this room, I'll keep with EU West 1. So that is actually all the code that we need to do to init Terraform. This will inspect our code and see which provider we're using. It'll then go and fetch that provider with all of the resources we can use down into my local file system, into that .terraform directory that we've seen previously. on our lightning fast network, you only need to Terraform init every time that you introduce a new provider. So once this completes, in fact, I'll just open up a new tab while that's downloading. We can jump in and start adding our resources. But before we do that, let's create an imaginary app. So to take a simple real-world example, we might have a need for a VM, something to run an API. We might want to host our web app statically on something like S3, and then a database so that we can write records into. AWS has services for all of these things. So we have the S3 resource type, the EC2 resource type, and RDS, which couples nicely into our needs. And here's what it looks like in the overall provider. So we've already done the provider AWS. The resources just get pulled in as resource blocks, and the docs are great for pulling out all the required attributes for those. So now that we hopefully have downloaded, I will start to spin up my resources. So the first thing we're going to do is ask Terraform to create an S3 bucket for us. That's the first of the three components that we want for our imaginary app, a place for us to store our HTML, CSS, and JavaScript. And this is the easiest one by a margin, because technically this is all the code you need to write to deploy that. I'll make it a little fancier by giving it a specific bucket name. Hello, IDC, something. The only point to note here is whenever you're naming your bucket, it does need to be unique across the entire region, so you'll almost certainly hit errors if you call it my bucket. Just something to keep in mind. So now that we've done that, and I'm going to make an assumption that the previous Terraform init finished, we can actually tell Terraform to apply that configuration. The first thing it'll do is create a plan for us so we can see exactly what resources in AWS that we're requesting to create. Here you can see green, we're creating an AWS bucket called my bucket. We have the value that we passed in for the bucket name. But everything else, it just assumes that you want the defaults. And at the bottom, it tells me I'm going to add one thing, 0 to change and 0 to destroy. So given that I'm happy with that, I can say that's fine. It will go off and do the thing, and it's finished. And just to prove that that actually did something, ta-da! So we have deployed an S3 bucket from code. So we have 2 more resource types that we want to add, the next being a VM. So we can open up our file again, create another resource type. And just like before, we give it a name so that we can reference in code later if we like. VMs on AWS require 2 fields, and you can see this from the documentation here. For AWS resource, you get a list of all the available options, but only 2 of them are absolutely required. The AMI, which is the base image. If you're not familiar with the term, if you imagine the disk that you'd like to boot your server with. And the instance type down here. The instance type is how big the machine is going to be. So whether you want 2 CPUs, well, vCPUs, or 16, how much RAM you want, etc. So looking up AMIs is a bit of a pain in the ass. There is a command that looks like this if you want to look up the latest. It's in the GitHub project. I'm going to cheat and just, I stored this in my dot files earlier because I didn't want to show that. But now that it's in, let me see. Now that it's in, I'm going to, oh. Did I? There we go. I'm going to insert that value. So I'm going to tell Terraform, spin me up a VM, use this specific AMI, and the instance type that I would like to use is T2 micro. Again, I can go back to my Terraform apply. The first thing it'll do is a plan of the configuration that I have in my demo TF versus what's stored in my state file. And it will throw me up a summary. Notice the absence of the S3 bucket. It's seen that I only want to spin up a new VM. So the only fields of note here are that the AMI is exactly what I typed in, as is the instance type down here. So I'm happy enough with that. I let Terraform speak to the AWS APIs on my behalf. And after about a minute, there we go. We have our VM being spun up and managed for us by Terraform. The last thing I'm going to do is add a database. Adding a database takes a decent bit longer than spinning up a VM, depending on what database and disk size and scripts that you want to associate with it. It can take a while. I think the one I have can take 5 minutes, so I'll spin it up. I'll show you the creation of it, but we'll probably not wait for the apply create. Sure thing. Sure. Thank you very much. Yes, 1 second. DB instance, my DB. So database instances, just like VMs and other resource types, have a bunch of different required assets or required attributes. So I'm just going to quickly jump through these. So we're going to say that we want 20 gigs, and we want to use, we want a MySQL database. We're going to use instance class of dbt3 micro, username and password. So fairly standard stuff if you're setting up a database. The last attribute is just telling it to skip a final snapshot, and this is just to make the demo a bit cleaner for deleting things. So there we have it. In 21 lines, we've defined which cloud provider we wanted to use. We have said that we want to have an S3 bucket. We've said that we want a VM with some specific attributes, and we want a MySQL database. Terraform for the last time will go off and do its plan. It will see that the bucket and VM already have state. It will see that I have one new addition that I will create now, and it will go off and spin me up a database. Half time I'm flying ahead.
You are, you're doing great.
Okay, cool. And really that's it. The entire process of introducing Terraform to whatever your projects are typically start with you looking up at the providers. So if you work in GCP or VMware, the documentation by Terraform is terrific. So you can easily look up and almost replace the parts of the stacks that you're using with code, and very quickly bootstrap your entire infrastructure in that way. So a quick recap, and I think I've a bit of time to maybe do some ad hoc storytelling about why this is useful. So what is Terraform? It's a tool for building, changing, and versioning your infrastructure, which is really, really useful. A real-world example of this is years ago, there just wasn't tools like this, and I certainly was nowhere near along enough in my career to responsibly look after infrastructure, and we had a huge outage where essentially a bunch of the machines that were running the VMs that we had got wiped out, and there was we had backups of everything, but we had no quick way of getting the configuration right for how things were plugged in. So even though we could spin up a VM with a backup that was maybe only 12 hours, it ended up taking days for us to work out all the security groups and how databases were configured, and probably even months before we even got anywhere close to the fine-tuning that we had before. So you only really need to go through that kind of baptism of fire once before you realize there's probably going to be a better way of doing that. So we moved from there onto tools like, well, we'll still spin up the VMs manually, but we'll manage all the code using Ansible or whatever else, which is great, but Ansible only covers part of that story. You're still not really getting the description of your infrastructure there. Your security groups still aren't really going to be defined there. So Terraform came along 5-6 years ago and really revolutionized the way that you can manage your infrastructure, the repeatability that you get, the fact that the configuration language is super easy to read, makes things like doing PRs in a large organization really good, means that you're getting a bunch of different opinions about your infrastructure. You don't need someone to learn Python or Bash or whatever just to go and contribute. So it's been a huge helper for us. Sadly, we do use it in the bank. We have a couple of private data centers. We use various different public clouds. We don't use it everywhere, but we're kind of getting there. I am in a position as an SRE where I have to use all of the options and could say hand on heart it is the best option. CloudFormation, I'll leave that to a hallway chat. So why bother? If you have a bit more of a traditional ops background and you've been managing this stuff fine with bash scripts and stuff, it may not be obvious why a lot of what Terraform has to offer could benefit you. But as soon as you start doing things like pull requests with a larger organization, even with people who maybe have no background at all in managing infrastructure, just to get new perspectives and, well, where did you come up with these auto-scaling group parameters, and makes you second guess, well, maybe I didn't actually get those numbers right and we should crunch. All of that stuff's great. And what does it look like? It's essentially a CLI, a backend, and a configuration language. There is the enterprise option, which bundles like a web server and stuff for you, but I'll leave that out of scope. And the demo, the only thing I seem to bomb is I completely overestimated how much time it would take. So that's it. Any questions? Shoot.
Yeah, I've got two, I guess. The first thing I want to know is, whenever you created your database there, you were hard coding in the username and password for it. Is there a way to pass those through as config? Or
oh yeah. Oh yeah. So. Oh yeah, sure. So the question was that there were certain values in the configuration that I wrote which were hard coded. And the question was, is there a way to pass those through dynamically? Which is a great question. And because I have spare time, I'm just going to code that. So Terraform supports variables. In fact, let's not deviate. I'll just create it in the same file. So just like provider and resource, you declare a variable with variable space string. So we can call this uname and say type equals string. And then in my username, I can say uname. Now that I've declared a username, whenever I go to run Terraform apply, it will prompt me for a username. So you can either do this through standard in, or you could pass it in as an environment variable. So Terraform supports this construct of environment variable naming, where you would say export tfvar underscore uname equals x. I'm assuming I didn't misremember that. There we go. So it's automatically injected that for me. You can do it a whole bunch of different ways. It depends on your design as well. Maybe you want to spin up infrastructure and lay all that configuration external. So tools like Vault have built-in support for, you can essentially assign your VM a namespace on Vault, and then have it dynamically provisioned. That's kind of the ideal, because I, as an engineer, never want to know the database credentials. But yeah, good question. Any other questions?
Presumably because you're using the AWS CLI, then you don't have to give this kind of your AWS credentials.
Absolutely correct. So the provider block at the very top, in fact, let me open this up in Terraform. So great question. The provider. Oh, sorry. The question was, given that I have already configured the AWS CLI, the assumption is that I don't need to pass it any of my credentials. It picks that up from my environment, which is correct. But it is also optional. So let's say you want to run Terraform apply as part of a CI pipeline, and that CI pipeline is running on a worker that doesn't have the AWS CLI, and doesn't have those creds preloaded. You do have the option to set your access key in secret, and again, the same way you can inject those dynamically or whatever. But yes, the reason my code looks so clean is because another time in the past I set up the AWS CLI in my machine, which I can, for anyone who hasn't seen that, it looks like this. So my AWS CLI is pre-configured to look at that AWS account that you've seen, and you can see here that it's dumping out the same S3 bucket that we created in the demo earlier. So that's where that magic came from. If you don't have that, you can just inject the values.
Yeah, you can pull it from Vault as well, I guess.
Yep, can do. Any other questions?
Yeah, go one more. I don't have a huge amount of experience with Amazon as a whole. I do a lot more dev stuff, so anytime I've interacted with it, it's typically been with Elastic Beanstalk for spinning up cool stuff. And it always ended up being a nightmare if someone changed something through the user interface.
Yep.
And whenever you try to delete it again, it turned into hell.
State drift.
Yeah. So how does this help with that?
Yeah, great question. So the question was, it's like a fable general story for managing systems. You create your baby, it's singing, it's working really well. Someone comes along and misconfigures, fat thumbs something, and all of a sudden it's wrong. You don't necessarily know why. So before I answer your question, first I'll say what Terraform doesn't do. If you have an AWS account or any cloud account that has already got provisioned infrastructure, it won't automatically include that in its diff, because by design it thinks, oh, you only want to manage this new part, which is right, because if you do a Terraform apply or destroy, you don't want it railroading something that maybe you deliberately manage separately. But to go back to your question, that's exactly what the state file is responsible for. So whenever I did my Terraform apply, it dynamically generated this JSON file, which includes Terraform's view of what happened the last time it ran an apply. So this will include things like instance got the IP. So the allocated storage, for example, that's a better example. So let's say someone jumped onto the console and they changed that value from 20 to 30. The next time I go to run Terraform apply, it will notice that state drift. In fact, let me just do that. Database change is going to take a while, as is S3, VM, instance class. Well, that'll take a while. Yeah. I should have picked a Lambda. The only reason it didn't is because I didn't want to include the security policy of a Lambda, which would have been like an extra 30 lines. And I went really weirdly code golf on that demo and wanted it to be 12 lines for 3 different parts of infrastructure. But yes, your state file is responsible for that. To segue from your question, oh, sorry.
Oh, no. So just on top of what he was saying, so like if I delete a resource through the UI and I run apply, will it re-provision that resource?
Yes, but there's no guarantee that it'll be the same. IP pools can get swallowed up. So yeah, that can be trickier. But yes, it will certainly go ahead and recreate, which can be great and annoying as well. You know, if you're manually nuking resources and you want to like add something onto it, it'll correct through an auto-scaling group or something like that, the number of VMs that you have. But yes, it will do that, but no guarantee for dynamic IP allocation again.
I guess the end goal then is that people don't have access to go onto the UI and change things. They do it through this, and then it's managed by Azure control and request and things.
I'd say that's more an idealism. Certainly every time I go to design a system that uses this through CI/CD, I'm like, yeah, devs will never know that this exists. And then, you know, the realization of actually it's still really useful to jump in the console and debug things visually. The Terraform CLI should absolutely be the only way someone creates something. But like early on into the development cycle, it's kind of healthy to jump in and maybe just tweak some things really quickly in the UI without necessarily worrying about, oh, I'm going to update the code and go back. But you're bang on from an ideology perspective. Nobody should ever need to jump into the console, but it's still a useful tool to allow everybody else to jump in. Yes?
If you're a business or making a solution that's designed to run in some customer's Amazon setup, would Terraform be an effective way of delivering the solution to a customer if you need to spin up parts of the components that make your product work? And if not, why not?
So the question is fairly complex. In a scenario where you have a customer, let's see if I get this right. Scenario where you have a customer and you want to deliver a product to their pre-existing AWS account, that you provide them the Terraform that they can then do Terraform apply in their environment. Did I get that right?
Yeah. Built into that, but would it be a good way of delivering?
My knee-jerk wants to say no, but I can't think of a single reason why not. You're providing someone infrastructure as code. You have things like environmental drift. You know, there's of course the chance that you provide someone Terraform 0.12 compliant code and they're running 0.11 or 0.10. They haven't done an upgrade and there could be a breach, but you're going to generally have that for any scenario where you hand something and ask them to execute it for you. So no, I can't really think of an environment, assuming that you have already tested that it's okay in their region, that if they have a pre-configured VPC, for example, that the CIDR ranges don't conflict with things in your code. Don't want to get into network stuff, but assuming all the boxes are ticked and the environment passes a health check, no reason why not. I imagine it would be done with ribbon and customer support and a bit of hand-holding, but yeah, no reason. I was going to segue onto your point, but I've forgotten. Oh yes, last point on state. As mentioned at the start of the talk, this is the default backend, which is the local state file. If I'm working with 2 people, we get 2 different ones of these, each on our own machine, which will really start messing things up. To bring that into Mark's point, that means if you add a VM and I add a VM, whenever I deploy mine, I'll delete yours because yours isn't in my config. So that's when you move your backend to S3 or something like that. No time left. That's me. Thank you.